Welcome in our math session in YouTube. We will complete our sessions here, so please concentrate well. We will start with new thing and it's called the area. But before we start it, we will revise the perimeter. So, if we have a rectangle like this one, to get the perimeter, you know that we will add all the outer lines that we have it. So here we have here, if you look, we have here, this is the longest side and we have the shortest side, and of course you know that the longest side called length and the shortest side called width. So to get the perimeter, we have to add all these sides. But before we start, you know that each two opposite sides are equal. So this is equal to the opposite side and this equal to the opposite one. So if we have the first side up, it equals 5 centimeters. So of course the opposite side will equal 5 centimeters. If this is 4 centimeters, so the opposite side will be also 4 centimeters because they are equal. Okay, to get the perimeter, you know that we will add them together. So we can say it's 5 plus 4 plus 5 plus 4. So 5 plus 5 equals 10, plus 4, 14, plus 4 equals 18, and this is the first one. And we can calculate the perimeter for this figure also with another way, with our rule. This is a rectangle, so of course we will use the rule that said length plus width times 2. So we will say 5 plus 4 equals 9 times 2 equals 18. Here's length plus width times 2. 5 plus 4 multiplied by 2 equals 18. Okay, what about the new things that we will take today? And it's the area. The area is not like the perimeter. The perimeter was taking only the outer lines. But in the area, we will take all the space that this rectangle cover. So we will take all the highlight part here, that we will highlight it. All this part is called the area. So the area is the covered space inside this figure. But how can we calculate it, or how can we know it? Before we calculate it, we will take its what. So the area is of the rectangle or any figure. The area of a shape is defined by the number of units which consists that shape. Here it is, the definition. Okay, so how can we solve it also? If we have a figure like here, the opposite one, how can we calculate the perimeter for it and the area? So we will start with the perimeter. We take before to calculate the perimeter of any figure or a figure like this one. You know that we count all the small lines or the small units here outside. So we will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the perimeter for this figure equals 16. Okay, what about the area that we speak about today? The area we will count according to the units that we give it to you. It's a small rectangle or a square. We will count all the small squares. So we will count together here. If you look, here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 13 squared units. Again, we will count according to the units that I give it to you. It's a small square, so we will count the small squares again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they are 13 squared units. Okay, so we'll take a new one. Here it is. We have a square and it's divided into small squares. Again, when we count the perimeter, we will count the outer lines, and together here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the perimeter equals 12. Okay. And we know, of course, this is a square, so we can say its side length times 4. The side length here equals 3, 1, 2, 3, so 3 times 4, and it's equals 12. Okay, what about the area? We will count the small units that we give it to. The area equals a square, so we will count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 squared units, and this is the area for this one. Okay, a new one, but this is divided into a different figure, so we can calculate the area according to the units that we give it to. We give you here in this question a small triangle, so we will count the small triangles in the figure because it's divided into small triangles. So together here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So the area for this one it's equals 32 triangle unit. So we're counting the area according to the units that we give it to. And the first one was a squared, so we were counting squared. Here it's a small triangle, so we are counting the small triangle. Okay, a new one. Here it is this figure. We give you the unit, it's a small triangle like last one, so we will count the small triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So the area for this figure equals 25. And new one, again with small triangle. We will count together the small triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So the area equals 32. Okay, look at this one and concentrate very well, because at the same figure we're asking you 3 questions but with different units, to make sure that when we get the area we have to look at the unit because it will be different. At the first one we give you small triangles, so like the last 2 times or all of them we're counting according to the unit, so we will count here the unit. A triangle, so we'll count triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the area according to the small triangle equals 16. What about the next one? We give you a square, so we will count the squares and we will see together here. This is a square, so we will consider it as a 1. So here it's 1, 2, 3, 4, 5, 6, 7, and it's 8. So according to the small square it's 8. So when it was triangles, it was 16, so we're counting the triangles. As squares, we will count the square, and in this case it's 2 squares, so we will consider that each 2 squares like this as 1. So here we will clear it first to know how can we make it. Okay, so we will take each 2 squares together. Here it is, the 1, 2, so they will be like 2. Here it is, this is 1, 2, 3, 4, so they are 4. So look at the 3 questions, it has different answers even if we have the same figure, so concentrate about the units that we give it to. The opposite figure represents large rectangle divided into 2 rectangles. Here it is the large rectangle, all of it, and it's divided to 2 rectangles, the yellow one and the red one. And here, this table, the red rectangle, we want to it the perimeter and the area. So the first thing, we will get the perimeter for the red rectangle. Here it is. To get the perimeter, we're counting the outer line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the perimeter equals 10. What about the area? We're counting the inner rectangles. So here it is together. 1, 2, 3, 4, 5, 6. So the area for this red rectangle equals 6. What about the yellow rectangle? We will count also for the perimeter the outer line. So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the perimeter for the yellow rectangle equals 14. What about the area? We will count the inner units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area here is 12. What about the large rectangle? To get the perimeter for the large one, the perimeter, we will count the lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we are counting the outer lines to get the perimeter. What about the area? We will count all the units inside it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the area equals 18. If you look, that you will find the perimeter for the yellow and the red, if you add them together, will be 10 plus 14 equals 24. But the perimeter for the large one equals 18. So the plus for the two perimeters not equal the large one. But if you look at here, 6 plus 12 equals 18. So the sum of the two areas of the two rectangles equal the area of the large one. The last one. And the following figure. Here we have a question. Do the three opposite shapes have the same area? And why? So that's mean we will count the area of the three figures. 1, 2, 3, 4, 5. The area equals 5. What about here? 1, 2, 3, 4, 5. So the area also here equals 5. Let's check the last one. 1, 2, 3, 4, 5. So the area also here 5. So here the question, do the three opposite shapes have the same area? Yes. Why? Because they have the same area, and it's equals 5 units. Okay, a new one at the same one. Search if they have the same perimeter. So to know the perimeter, we have to count it for each one of them. And here it is, the perimeter for the first one. We will count only the outer line. So here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the perimeter for the first one equals 10. What about here? The perimeter equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the second one equals 12. What about the last one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the perimeter for the last one equals 12. So they have the same perimeter? No, because if you look, you'll find that this is 12 and this is 12 and this is 10. So here, no, because the perimeter of the first figure equals 10, the second one equals 12, and the third one equals 12. Thanks for watching grade 3. Waiting for you for the next time.